Alrighty, welcome everyone to Windows Week. This is going to be very dense. There's a lot of information. Try to follow along as much as you can. I'm going to have a question break in the middle in case you guys have questions about anything in the middle of it. So to start off, here, let me move. I need to turn this video off so you guys can actually see. There we go. Alrighty, so what is Windows? Windows is a graphical operating system. We went over Linux last week, which was a lot of command line and there was GUI options, but Windows is pretty much almost a completely graphical operating system. Excuse me. The kernel is the Windows NT is the kernel part of it. And then you got Windows servers, which is like Active Directory, DNS. There's a bunch of services already on them. There's also workstations where you're pretty much your basic Windows computer. You're going to have, a lot of us have them. They're just what Windows is. So you can download programs, run programs, etc. Then there's Windows IoT, which was formerly known as Windows Embedded, which you can, for some reason, flash on a Raspberry Pi. If you want to do that, I would not recommend that one. There's also another one that's really popular now called Windows Core or Server Core, and it's Windows without a GUI. It's there are GUI aspects to it, but it's mostly PowerShell, and there's no default GUI on that. Windows is so why do you care? Windows is the most popular form of like operating systems nowadays, whether that be in home and in companies. It is extremely well used. So it's a super important skill to understand and know what Windows is and some basic functionality to how it works. So now we're going to get into the file system. The file system, the primary name of the file system is NTFS, which is the Windows NT file system. So that's where the name comes from. Each drive, if you're unfamiliar, gets its own letter, the default being the C drive. If you ever see C:, or if you install a new hard drive or plug a USB in, you'll see that there's D:, or E:, or you can even give it its own name if you install your own drive. Some super important directories at the top level of the C:, drive are your users, which contains, it's very similar to the, I believe, home directory in Linux. It contains all the users directories. That's where all their files, their desktop, their documents, and all those other files are stored. So if you have a large server, that's where you're going to see all the users' profiles and all their files set up. The Windows/Windows folder, this is where a lot of the core Windows, this is where Windows is installed. This is where a lot of the core programs are installed on Windows. You're going to find a lot of extremely important programs. System32. System32 is where all the DLLs and a lot of the vital core Windows programs are stored in. So that being the meme folder where it's like, oh no, delete System32. That would actually really mess the system up. And in Windows 10, there's a lot of protections against deleting System32 just because it's such an important directory. Then you have your program files and program files x86. The big difference there is on the 64-bit. That's where on a 64-bit version install of Windows, which is what most of you probably have now. It's where all the 64-bit programs are installed. If you don't have the 64-bit version of Windows, it's where the 16 and 32-bit programs are installed. So the x86 one appears on the 64-bit edition of Windows only, and this is where they make a separation in Windows between where the different programs run. And this is mostly for backwards compatibility, but there are other programs that just aren't as many compiled to be 64-bit programs, so that's where they would put them. And then there's your program data folder. This is where it's expected to be accessible regardless of any user. This is where all program data is stored. Regardless of the user, you can access this folder. It's a very generic directory, so you'll find some information in here if you're ever looking around. Alrighty, so now the registry. Everyone's favorite thing. Windows is infamous for the registry. So a little bit about the registry. It's a hierarchical database that contains configuration options. So to break that down, what that means is it pretty much is just a database to store different kinds of settings for different types of users. So programs can use the registry, but you can opt in to use the registry. And what that means is you'll store some of your program settings in the registry. So say you have Office, for example, you can take some of your office settings and just a quick example. I don't think this is accurate of what actually happens, but say you want your default font size to be 11 whenever you start Windows, like a document. You could technically make a setting in the registry that says, okay, I want my font size to be 11 whenever I open a new document. So it's just where you store settings. They're stored in a key pair value. And you'll see this once you do the challenges. There is a key, which is what is being stored here, and then a value for that key. So for example, in that picture, it's just set to default and they don't have a value set. It could be set to run this program. The key could be run this, and then the value would be a command to run the program. So it's really powerful, and there's a lot you can do with that. You can put strings. D words are a type of integer. I'm not going to get into those. You can put arrays, all sorts of types of data in the registry. And about the registry, there is there's varying different root keys for what different types of data are stored in the registry. HKLM, which is the H key local machine. This is where all the settings for the local computer are. These are run either once the computer is started up, or this is something that is adapted to all the users' configurations once they are made newly and there's no other settings set. Then there is the HKCC, which is the current user configuration. This contains information at the runtime. This just has a temporary settings that are needed to run Windows. Then there's HKCR, which is information about the registered application. So these are what registered applications you usually use. These are one of the root keys that they can use to store their settings. There's HKCU, which is the current information about a user, and at the same time, there's HKU. So HKU and HKCU are related. HKU has all the users' settings for those users. So every user has an HKU where all the settings for their personal user account is stored. And when they log in, if they check their HKCU, their current user one, it'll be that link to that one, and it has all the settings from that one. Also, if we have questions, I'm going to check the Twitch chat periodically. If there are questions, I have a question break in the middle where I'll give a pause and give a second for questions. So now the Windows users and groups. So Windows sections off their users in different groups. So they're very much different from how Unix does their users and groups, where they just have numbers in Unix and different group numbers and different user numbers. Every user and group is granted permission off of a SID or security identifier. And this is huge to Windows security. So this is a unique value assigned to any user, group, or session. They all have unique SIDs, and that's how Windows can tell these things apart. There are a lot of different groups with varying permission levels built into Windows. I believe you can make your own groups, but a lot of the default ones are extremely powerful, and you can use group policy, which we'll get into later, to really have fine-grained control over your users. The highest level of permission in Windows as a user is an administrator. There are system users. So there's built-in service accounts. These are running on different privileges. We'll start with local system. Local system is like the equivalent to root on Windows. If you're an attacker, you want local system. If you're a defender, you want to defend the local system user. This pretty much gives an attacker as much power as they need to do almost anything they want. But with that, there was problems with that, and they created local service and local network service user and a trusted installer user. These users are used by the SCM, which is the System Control Manager, and we'll get into that. There's a whole slide about services. And this is what Windows uses to install services, install different programs, run certain programs. These users have minimal privileges. They cannot do everything. If you have a service, you want them to have least privilege. You don't want those services to run things that they don't need to be running. And that's what these users are for. It's to help build an isolation on like a sandbox where these services can run, do what they need, but they're not accessing random things on the workstation or server. So process permissions. Process permissions, they all resolve around access tokens, and you could give a whole talk about access tokens. These are very complicated, but the main thing about these access tokens is that they consist of SIDs for the access and the privileges. So what privileges do these tokens have? Here I listed some dangerous privileges that you really don't want to see on like an industrial or a production server. SE debug name is for debugging programs. You really don't want debug anything on a production server of any kind, because this normally gives way too much information about the program, or will allow for an attacker to possibly leverage some debugger stuff that is present. Assign primary token name replaces process level tokens. That's kind of dangerous. Take ownership token allows you to take ownership of files. You really don't want that on your system if you're trying to not let everyone see your file. Act as part of the operating system, the TCB name. This is another one you really don't want to see on a production server. iCackles is a really great command line tool to actually look at the permissions of a file. As you see here, I just ran iCackles on this PowerShell script I had laying around, and you can see the different kinds of you can see the different kinds of permissions on the tokens. There's a lot more parameters you can pass into iCackles, but I'm not really going to get into that. You can look up iCackles on MSDN, which is the Microsoft documentation website, and there is paragraphs and pages on these tokens and different things. And then that picture on the bottom right there, those are just processes running on the system. I'm sure you've all seen task manager processes. There's a lot you can do with that, and we're going to get into system internals later, which you can do even more than what task manager has. All right, user access control. This is one of the big security things that Windows does. And we're going to start, what is access control? It prevents people with lower privilege from accessing higher privilege. And how does it do that? Well, it makes that little pop-up on your screen, and you have to click yes. The big ways to get around UAC are there's some bypasses out there, and you have to click yes on that little box. If you don't click yes on that box with proper credentials, you can't do it. So how does that help Windows? Well, if you have say a low-level user, or say you have a network and you have a bunch of employees and you have administrators. Say an employee got hacked, you can't, as an employee, run as a higher trust level than what you're allowed to run as, which will inherently protect the operating system. It will make it more isolated. So there are multiple trust levels, and that goes from untrusted, low, medium, high, system, and protected. So if you are a higher trust levels can run lower trust level stuff, but lower trust levels cannot get to the higher trust level stuff unless they bypass UAC in most cases. So this is a really good feature that was added to Windows that has protected medium and low and untrusted users from running higher privilege stuff. So when you use UAC, it elevates you from either a medium integrity to a higher integrity. And if you open up sysinternals when we talk about it, you can see there are processes running a system. There are processes running as high integrity. There are processes running as medium integrity. So getting past UAC is a huge advantage as an attacker. Alrighty, I think this is the last slide before we do questions. So file permissions, there's a lot of file permissions is big in Windows. Each file has its own permissions that you can control with access lists. Access lists are made up of access control entries, and access control entries specify SIDs with those tokens and permissions in those tokens. You can do this in a multitude of ways, either on your local system. You can be an administrator and do this. You can do this through group policy. There's a lot of different ways to do this, and there's a lot of different file permissions. It is much more complex than the Linux file system, where there's a group permission. I believe it's group, root, and group like admin or basic user. I'm not a Linux wizard of any kind, so I'm not 100% sure what each section is. But in Windows, there's basic reads and writes, which are pretty self-explanatory. I'm not going to read the slides out. You can list folder contents, obviously, for directories. You can read programs and execute them. There's a modify permission. Then there's a full control. If you're an attacker, you want full control. You want to be able to do anything to any file. And vice versa, if you're a defender, you do not want an attacker to have full control. That is a big, scary thing. So I'm going to do a question break. I'm going to check Twitch chat and Discord chat here. Are there any questions about anything we've talked about? I'm going to give it a hot minute. Why is read and execute not just execute? To be honest with you, Windows is a very large operating system with it's been built up off of many, many years. I'm not 100% sure why there is a read and execute. Probably a read and execute is to group together. You can read the program and execute the program, but you can't modify the program. That'd probably be my best guess. Alrighty, I'm going to continue on. I will have time for more questions at the end, and you can always reach out. Alrighty, so now we're going to get into some more in detailed topics rather than just an overview. So the command line. The command line is old and clunky, and it feels like very much like shit when you're using it, to be honest with you. It's a DOS batch language. If you've ever written batch, it's at best, I'd say, but it works. And some of the basic commands to like run through the operating system are essential and extremely powerful, even though they don't feel like it. Here are some basic commands to run, translated to Linux, which we've used last week. Dir is ls, type is cat, which is where find is important. CLS is not, CLS is clear. Clear is not clear. I'm very much, I alias in Linux CLS because I think that one's better. System info will get you a lot of information. We still have netsat. If you want more, there's a lot of commands, and the command line can be very powerful. There's a resource link there. The slides will be posted after the talk, so you can go check those out if you need more help. /? Is how you access help in the Windows command line. Yeah, but now we're going to get to PowerShell, everyone's favorite thing. Everyone loves PowerShell. I personally don't, but that's just me. I don't like .NET. But so this is what Microsoft built in order. It started very awful. It was terrible. But over the years, it's become an extremely powerful and useful language in like command line interface. This is what they did to like, answer Bash being so much better than the CMD. It's built over .NET. It's extremely powerful. It's based off objects and not just text, so you can do a lot of really powerful things with it, and I'll get to that in a minute. The basic things are you can do git command, and it will show you commands, and you can get command tag module and name the command, and it will actually give you help about the command and give you a lot of different information about the command. Get help also gives you a lot of information about the command. There's a lot of different resources, and it's very well documented all over MSDN, which is, again, Microsoft's documentation. So there's a lot of resources on PowerShell, and it's extremely well documented nowadays. So here's a basic PowerShell command just to get everyone started with what it would look like. So for each objects, replaces what a for loop would be in PowerShell. You can use a where object to filter output. The money sign underscore, if you're unfamiliar with programming, when you iterate through a loop, for each loop, it takes each object. So for example, here we have get service. So get service on its own lists every service running on the system. And that might be useful later, just demo time. And you can iterate through each service. And if you pipe it like Bash, you can pipe into stuff. If you pipe it into the for each object, you can now access each of those services individually, and you can run logic on each of the services individually with that money sign underscore. So this program, I believe, will just write all the services out just as get service would, but you can perform logic on that if you'd like to. And this is where PowerShell becomes really powerful. Alrighty, so now into everyone's favorite Active Directory. Active Directory is something you will see in the real world a lot. Active Directory is known as the domain, Active Directory domain service. So you'll see ADDS a lot when you're on the Windows servers. This is a LDAP authentication type of system or service. So how does it work? Well, how is it organized? They create what's called a forest. And within those in the forest, you can have domains. So that domain being on your local system, it's probably some sort of local host ordeal. RIT, you have your rit.edu domain. There's a lot of different types of domains you can have within one forest. Commonly, you'll see just one, but you can have many. So it's just like the Linux file structure or like Windows file structure. It's a tree-like thing. So you'll have your highest level, and it'll branch off into lower levels. So it stores information about the domain. So what does it store? It stores information about different computers on the network, different users on the network, printers, and these can all be grouped into different OUs. And you can do there's classes on Active Directory, and there's a lot you can do with Active Directory, but I just want to brush over the top level of it. So in these OUs, you can assign permissions, you can assign users permissions. It really allows you to have extremely fine-grained control over your server, your network, who can do what, and what users can do what, or what groups can do what. Like you can put all your printers in there, and you can assign that the printers should not have any domain admins logging in on them. And why should they have domain admins logging in on them? And we'll get to what those are in a moment. Next slide. So yeah, they've been really pushing, Microsoft has been pushing companies to use Azure AD. And if you're unfamiliar with Azure, it's just a cloud service. It's Microsoft's cloud service. And Azure AD is extremely powerful. And that's something that Microsoft has been pushing a lot more now in the cloud days. So that is something you'll see commonly in environments as well. So more Active Directory. Here are the main admin users that you want to look out for in Active Directory. They have the Enterprise Administrator. This is the administrator that can control everything in the entire forest across multiple domains. This is something that you want to be careful giving out permission with. Then there is the second highest one, which is the Domain Administrator. You also want to be extremely careful with this because this is the highest level privilege in a domain. So enterprise admins are an entire forest, so they can access all the domains on the forest, and domain admins can only access a specific domain. So you can log into any computer as local admin. You can do pretty much anything on the network. In a competition or in the real world, you don't want everyone to be domain admin. This is not a very good practice. This could allow for a lot of problems in your network. Then they have specific admins. If you're just working on the DNS service, domain name service, we'll eventually go through that, I believe, in networking week and network services week. But pretty much it just translates IP names to IPs if you're unfamiliar. But DNS admins can only administrate the DNS service on Windows servers. They can't administrate anything else. Schema admins can only administrate, they have control over the actual AD database, that being the users' permissions, where the users are, the OUs, all that stuff, the good stuff we just talked about in the last slide. And then domain users, this is an average domain user. They can't install programs by default. They can log in. They can use their default programs. They can't do anything with a high privilege level. They need to use UAC to get by, to get a high privilege level. And hopefully you have your UAC protected, and not every domain user can do everything on your network. Alrighty, group policy. Group policy allows you to manage all your workstations you have on your domain. This is a very, very, very powerful thing that a lot of people should use. From my experience, some people don't like using it in the real world. A lot of people do. It's a very, very powerful service. There are so many options. Like I have listed, there are 5,000 plus settings that you can push to computers. You can restrict local admin account. You can restrict certain programs based off the name of the program. So for example, you don't want your normal domain users, you don't want accountants using command prompt, because why would an accountant need to use command prompt? You can block all normal domain users that don't need command prompt from using it. And this will stop an attacker if they get the accountant, because they won't be able to run any commands with command prompt. So that's a really good tactic to use, is blocking programs that aren't needed. You can disable control panel, disable task manager. I'm sure a lot of people from high school, you couldn't get the task manager. It was probably a group policy that literally didn't allow you to open the program. So group policies can be extremely effective to push out settings across. When you get to larger domains, it's extremely effective to push group policies to your 5,000 users, and then all 5,000 of them have the settings. And there's a little meme right there where you can push group policy update from the domain controller, like the main Windows server, and then you can do /force, and it just forces it to do it right now, which is the kind of the joke, because you just /force it and then it goes right away. All right, so that's a lot of stuff in Windows. There's a lot of stuff. How do we look at all this with all the garbage Windows tools like Task Manager? Well, easy solution. You use sysinternals. Sysinternals is a very large group of tooling that has been created to allow you to get way more information about Windows internals. The big one you'll probably use a lot in competition is Better Task Manager is like a lot of people like to call it, but it's Process Explorer. There are some other ones out there that aren't a part of sysinternals that are really good as well, but I'm going to talk about Process Explorer because it's the main one. This allows you, as you see in the picture, to see programs, child processes of the programs, how much memory they're taking up, their process ID, which can be important for making sure when logging malware, seeing where malware's at. You can see the integrity level. So as you see, my explorer.exe right there is running as a medium integrity, as it should be. It is normal because I am not a domain admin, and I believe it always runs as medium. And Chrome right there runs as a medium one. But there's some other services that need to run as high, so those are running as high. There's a command prompt down there that's running as medium because I did not right-click run as administrator. Procmon is really good for debugging. psexec is a really good one for remote commands. This is big. We're going to talk about this in a second. Sysmon is really good for logging. TCP view is really good to look at visually look at the connections coming into your system. Auto runs, another one I forgot to put on here. Auto runs is really, really good for looking at registry keys. It'll show you registry keys that aren't supposed to be there, could be potentially malicious, could look in potential registry locations that people like to use for persistence. Hint, hint, maybe you want to download that and use it. Services. Services are, I forgot to put a meme. Services are similar to daemons that we were talked about in Linux last week. So they are run all the time in the background usually. They are controlled by SCM, the System Control Manager. SCM controls all the services running on your machine. They run in the background all the time, such as the daemons. You can run a service as system user, which could be very dangerous, but as an attacker, as a red teamer, I like my service running as system. You might not like it, but we can share the machine, and I like running it as system. And then there's the other users, the network service user and the local service users. This is what you want. You want these services to have as little permissions as possible that they need to run, so bad people like me or other attackers can't break into your system during a competition, for example, and get full advantage of it. They can be running when no one's logged in. They can be either started automatically on machine startup, user login, triggered by some event, or you can manually start them by yourself. Here are some ways to install, stop, or remove services, which might come in handy. Is you can PowerShell, you can do new service, name the service, the binary that's going to be running the service. You can do a description as well. You can do command lines, screate, your service name, the binary path. It's very similar command. The only difference is one's CMD, one's PowerShell. People prefer PowerShell. People prefer CMD. Also, the services.msc is that a program you can use to view all your services that are running on the machine. I believe one of the sysinternal tools also does that. But if you don't have sysinternals, this will allow you to view most of your services. There are ways that you can make services not visible to that services.msc, but that's a whole nother thing. 2 more slides. Bear with me. psexec is the closest Windows will get to PowerShell pre-Windows 10. Now, this is pre-Windows 10. I believe that Windows has almost fully implemented SSH. Someone can correct me if I'm wrong, please, in chat, but I'm pretty sure there's SSH. I've used SSH on Windows. To actually get into Windows, I'm not 100% sure, but you can use SSH on Windows now without PuTTY, which is fantastic. It allows for your remote. It's common to see it because you can have remote administration through the command line other than just using group policy and RDP. RDP is really, really good for remote administration on the command line, or remote administration in general, but sometimes you don't want to have to RDP into a bunch of different machines. So you'll use psexec and you can script a lot of stuff, or you can remote into a machine real quick even while someone is RDP'd into it, which means you can do stuff during business hours. And it's really, really good for accessing a machine remotely. You'll see this in competition a lot of the times. A lot of times the red teamers will take advantage of this if the black team has it installed, or if the red team decides that the black team didn't install it because they know we'll take advantage of it, we'll install it ourselves. Oops. And this, for example, this command right here will allow me to log in to this machine, that random IP that I put, and log in as jbauer user. as a CMD, it'll start a CMD instance, and I'll have a CMD instance into your machine, and I can do whatever I want. I can start PowerShell. I can do all sorts of cool things to your machine. So you really kind of want to protect against PSExec in a competition environment, but also you could use it to get back into your machine. So this is just something, it's a very powerful system internal tool, and you want to keep an eye out for it. There are also PowerShell versions of it, but I don't really use those, so I'm not extremely familiar. There's a lot of different tools with Windows that you can use. Some fun things. This is more of a meme that we used to do last semester when we were all in the labs all the time. We're not all in the labs all the time anymore because, you know, coronavirus. But some fun things you could do in the labs are do PSExec into the lab machines, and you could hypothetically shut down someone's machine remotely because PSExec is installed on all the lab machines. Don't do this to be malicious if someone's working on work, because they are, all the machines in the lab, if you don't know, are deep freeze, and they will reset all the files off the system when you reset them. So yeah, that's a fun little joke you can play at night though if someone's just messing around. Alrighty, lastly, Mimikatz, a very, very powerful and popular tool that I want you all to know about because it might come in handy in your future. Mimikatz, here's a quote from a website, but without reading the slides, it pretty much just dumps passwords from memory, hashes, or other important information from memory in Windows. How Windows authenticates is it passes the password to a service in Windows, and you see that in memory, and you can intercept it with Mimikatz. If you see on the bottom right there, the one user, this is a good password 99 exclamation point. This is some picture I just pulled off the internet. You have the username, you have the password, the domain they're a part of. So you can get a lot of information with Mimikatz just by snagging the information right out of thin air. So there's a lot of resources on how to run Mimikatz. It can do a lot more than just this, but this is really the big thing that a lot of people use, and it's been around for a long, long time. It's a very powerful and extremely useful tool. I linked some resources to an in-depth guide of how you do the password getting from memory. And also there's some links below which explain Secrets Dump, which is a Linux version. I wouldn't say the same as Mimikatz, but it does a similar password dump as Mimikatz. And it does it from the Linux machine. So not for Linux, but you can use it on Linux on a Windows machine. This allows them, there's some documentation also of how to actually use this tool. Alrighty. So I know that was a lot of information really quick, but I really would like to take quite a couple minutes to answer questions or go back and explain things if people are confused. I have Discord up. I have Twitch up over here. So I'm going to start going through questions. Hold on real quick. Let me pull Twitch up. Let me pull Twitch up on my desktop so I can just read it from here. Alrighty. Isn't there a newest version of Mimikatz called something else? Yeah, I think there is Kiwi. I'm not familiar with it. I haven't used it a lot, but I know it does a very similar thing. Any other questions before we start demo? I really would like to, or not demo, I'm sorry. Tenchi, I believe, is going to give a presentation on last week's demo. So he's going to walk through how to do some of it. So if you were confused on last week's demo, now is the time to stay tuned. But I'm going to do one more check for questions, a final call, and if I don't see any, I'm going to hand it back off to Philip and Tenchi. How do I become a Windows god? So I don't have it in my room right now, but you should read the Windows System Internals book several times. But an actual answer to that question is it takes a lot there's a lot going on in Windows, and you just need to sit down and play with it and learn it. Don't use Windows just to use Windows. Use Windows and try to understand how it works and what different things are going on when you're doing things. Look up different ways to attack it. It helps you learn how to attack and defend. The biggest thing I did to learn a lot of Windows things was to go on to the MITRE attack matrix and look at different persistent mechanisms and learn how to actually perform these, and that helped me gain a lot of knowledge on the operating system. Alrighty. With that being said, go ahead. I'm gonna stop sharing my screen. Go ahead, everybody. I think is Tenchi in here? Oh yeah.
Yeah, Tenchi should be in here. Yeah, Tenchi. Yeah, there you go.
Hello? Can everyone hear me?